So on this first example, I noticed that, yay, there's a constant on bottom, and there's a variable on top, but it's not an x. So when I do this one, I'm going to plug in that variable and then take the derivative of that variable. So it's going to look like this, t cubed, and then the derivative of that variable would be 3x squared. Sorry, I forgot that I was actually plugging it in. Not t cubed, but x cubed. I fixed the boo-boo. And then of course I could simplify. I can take the square root of x cubed, which will be another x on the outside. So then I'll have 3x cubed, and then the square root of x. Or if I want them all together, I can have 3x to the 7/2. Not too bad. So on the next one, I go, yikes! I have a variable on bottom and on top. So I can very cleverly fix this one by splitting it. So I'm going to split, and for the first one, I'm going to go from negative x to 0, because that'll give me a constant. And the second one, I'm going to go from 0 to x. And then I'll notice, hey, look, over here I put a constant on bottom. So I'll be able to just plug this one in. So this one is going to be x cubed. But of course, over here on the first one, I still have the variable on bottom, and I want to put it on top. So I'll use the strategy that I used up above, which is I'll just negate it. And then I'll put 0 on bottom and negative x on top. And so while it's not exactly an x, sorry, that 3 got a little crazy, calculus is being persistent. So while it's not an x on top, I do know that if I have at least a function on top, I can plug in the amount, the function, the expression, and then take the derivative of it. So don't forget that I have the negative outside. I'm going to plug that in, so it'll be a negative x cubed, and then take the derivative of this, which would be a negative 1. And of course this is still plus x cubed. And so now, this beginning piece, if I cube that, will be a negative x cubed. And if I multiply that by a, oh, I forgot the negative out in front. I almost lost it. This one right here. So it'll be a negative x cubed, and then multiply by a negative 1, we'll make it a positive, and multiply by another negative 1, we'll switch it back to a negative. Whew, that was a lot of multiplying by negative 1s. And I'll get a total of 0. Now, on this particular problem only, I showed you the strategy that you can use with them. This one, there actually was a shortcut. I know you can punch me in the head tomorrow. And that this function is an odd function. And so remember with the odd function, if these two match, since it's symmetric with respect to the origin, and if I were to graph that, I could convince myself of exactly what's happening with that curve. So it looks like that, t cubed. And so if I'm doing negative x to positive x, keep in mind that this is going to generate a negative area, and this is going to generate a positive area, and they will in fact cancel each other out, and I'll get 0. So that would have been a shortcut, but that's one of those where you have to recognize it. And if you don't have that particular type of function where it's an odd function and that shortcut works, this strategy of breaking it up will always work.